Hello everyone and welcome back again. Here in this lecture I will talk about the second type of the power source, which is the standby generator. A standby generator is a backup electrical system that operates automatically when within a seconds of utility outage. An automatic transfer switch senses the power loss, commands the generator to start, then transfer the electrical load to the generator. The standby generator being applying power to the circuits after utility power returns. The automatic transfer switch transfers the electrical load back to the utility and signals the standby generator to shut off, and it then returns to standby mode where it waits to the next outage. To ensure a proper response to an outage, a standby generator runs weekly self-test. Most units run on diesel or natural gas. The automatic standby generator system may require by building codes for critical and essential loads. And of course, here is a picture for a standby generator, and here is a picture which we talk about in the panel for the chapter. This is an ATS, automatic transfer switch. And if I wanna to make more than one generators run together parallel and make the load sharing, I must consider three conditions. First, the speed controls, and second, the load balance, and final, the third condition is the synchronization. The speed controls mean the generators may have equal or different engine speeds, but must be looked into the final speed of the system. That means the same frequency. And for the load balance, the entire load should be shared by all the generators according to the capacity of the individual units. And for the synchronization is required to ensure that the resulting output in phase has the same frequency and voltage sense. And to apply all these conditions, there are a panel board called a synchronization panel. It have a sensors connected with the generators and the ATS, and it make all this condition. And this operation called the load sharing. And the load sharing is defined as a proportional division of the kilowatt and kilovolt ampere total load between multiple generators set in parallel system. And load sharing is essential to avoid overloading and stability problems on system generator sets. And for the generator specification, see here this table have the important specification uh, and requirement to select any generators. First, the rating, power, and second, the frequency, and also the voltage range for the single phase and three phase, and also the power capacity by kilovolt ampere or kilowatt, and of course the maximum rating current by ampere, and the breakers, the main breakers by ampere also, and the capacity of the foil tank, and the foil consumption by hours, liter by hours, and the running time, how can I make it run, how long I can make the generators run, and the dimension to install to prepare the room for the generators or landscape area if it outdoor, and the weight to charge the unit, and also the weight with the foil, and finally the sounds level by decibel. And also to size the generators, I must consider these four rules. First, make a list of items that need to be powered by the generators, and after that make a note of starting and running wattage of respective items, and calculate the total power requirements in kVA or kilowatt. After that, divided the total power by efficiency of the generators. That means if the efficiency of the generator is 20%, I must divide the total power by this percentage to get the final size of the generator.